As a DaVinci Resolve master trainer, one question I get asked a lot is what hardware do I need to run Resolve? And the truth is that there's actually quite a lot of factors that can affect performance within Resolve, or any post-production application for that matter. But one thing I always stress to people is how important your GPU actually is. I've talked before about video workstation requirements, and if you're interested, you can find out more information from our workstation buyer's guide. But what I want to do in this video is a deeper dive into how your graphics card can actually affect your performance within DaVinci Resolve. DaVinci Resolve is an incredible package with a fully fledged NLE, compositing package, color grading suite, and digital audio workstation in a single application. To drive all of this, Resolve performs all of its image processing on the GPU. If we think about what we're really doing, we're processing millions of pixels per frame with potentially VFX or color changes applied, retiming effects, noise reduction, and plugins, and we want it all to happen in real time. To do this, we're going to need some serious power, and this is where NVIDIA RTX GPUs step in. Now, a headline feature of the RTX series is their ray tracing cores, which are dedicated hardware cores to accelerate realistic lighting, but it isn't actually used by Resolve. But that doesn't mean that we don't benefit from the latest technology packed into these cards. To help me show off exactly how much of a benefit we can get from the latest RTX GPUs, I've got a 3XS Evolve Color 4K workstation that you can see just over my shoulder here, and inside that is an NVIDIA RTX 3090. Before we put this system through its paces, however, let's have a look at the full specs of the system. The system is built around the Asus ProArt Z690 Creator Wi-Fi motherboard with an Intel i9-12900K, which is a 16-core CPU. And it's been water-cooled to keep it not only away from potential thermal throttling, but also to help keep it quiet in a studio environment. We've got 64 gigabytes of Corsair Vengeance DDR5 memory, which is enough for us to work quite happily in the Fusion page when we're compositing. As I mentioned earlier, the GPU is an RTX 3090 with 24 gigabytes of memory, and this gives us both the power and the freedom that we need to work in 4K and higher resolutions. For storage, we've got a 1TB Samsung 980 Pro NVMe drive for the Windows 11 Pro operating system and any other applications that we want to install on there. We also have a 2TB Samsung 980 Pro NVMe drive, and that's for the cache, which is important if we really want to get the most performance out of the system. Finally, we have a 4TB Samsung 870 EVO SATA SSD for our media. It's definitely no slouch of a workstation, and if you were lucky enough to pass by our booth at MPTS, this is the exact workstation that we were doing Resolve demos with there. So let's finally get stuck into Resolve and see what it can do. So here we are inside the public beta of DaVinci Resolve 18. Let's start taking a look at the features and power that we get from using an NVIDIA RTX GPU. The first thing I'm going to do is I'm going to come up to this top corner DaVinci Resolve icon here in the top left. If I click on that and go to Preferences, it opens up my Preferences window. Now I want to make sure I've got the System tab selected and I'm on the Decode Options menu here. In here, you'll see we have an option called Decode H.264, H.265 using hardware acceleration. And underneath that, we have NVIDIA. What this allows us to do is use the NVENC encoders inside the GPU to hardware accelerate decoding of these heavily compressed files. These files are usually a bit of a nightmare when we're working in post-production. Generally, you'll come across advice to transcode H.264 or H.265 files because they're incredibly processor intensive. But with the NVENC encoders, the GPU can actually speed up the playback of these files. If I quit out of this and go to the Deliver page, you'll see that we also have our option here for an encoder as well. So it's not just decoding and playing the files back. When it comes to rendering the files out of Resolve as H.264 or H.265, we can leverage the encoders, the hardware encoders in the GPU to accelerate that as well. Now, if I jump across to the Edit page here, you'll see that I've made a very simple timeline with 3 clips on it. And my timeline is Ultra HD, 3840 by 2160. But this last clip in my timeline, the gentleman with the percussion instrument, isn't actually that resolution. It's actually 2K, it's lower resolution. So what Resolve's having to do is it's having to scale the files up. Now, this isn't a massive problem with this file. Resolve's scaling algorithms work really well, but if you were working on archival footage, for example, you might find yourself having to scale up SD to HD, or in some cases even SD to 4K for you to work on your project. Resolve has a feature called Superscale, and this leverages the Resolve neural engine to improve the performance, improve the output quality of its scaling operation. To get to that, if I right-click on my clip in the media pool or in the timeline, I'll select the one in the timeline, I'll right-click and I'll go to Clip Attributes. You'll see here that we have a Superscale option. I've already set it to ×2, but I could go all the way up to ×3 or ×4. If I set it to ×2 just for just now, we also have options for sharpness and noise reduction. I'll leave them as they are. I'll hit OK and I'll hit playback. You'll see that my timeline is playing back at the 24 frames a second. I get that small green icon to show me that it's playing back in real time. I'll get the same thing if I go to Clip Attributes and set Superscale to ×3. But if I go to Superscale ×4 and select OK, and then play the same clip, you'll see that actually it takes a while to get up to speed and the playback isn't completely smooth. That's because this process is really intensive and it requires a lot of power. Even with this RTX 3090, it can't do that in real time. Superscale isn't the only very intensive feature within Resolve. As we mentioned, Resolve performs all of its image processing on the GPU, and the amount of tools it has, especially the newer versions of Resolve, like DaVinci Resolve 18, it relies a lot on GPU power to accelerate these tools. Things like the AI functions, so Superscale is one of them. What I'm going to do is I'm going to right-click on that clip and turn the Superscale option off. Because what I'm going to look at is another neural engine feature, except this time instead of for scaling, it's going to be used for retiming. So if I now right-click on this clip again and go to Retime Controls, and you can see here it's currently set to play back at 100% of its native speed. If I click on the little arrow drop-down box and go to Change Speed, 50%, it now plays back at half speed. But again, if I look in my media pool here, I can see that the original clip was 24 frames a second. So what I've done is I'm now taking a 24 frames a second clip in a 24 frames a second timeline, and I'm making it play back at half speed, or 12 frames a second. If I hit play now, you'll see that the motion isn't exactly smooth. It's not great. Resolve's doing its best, but this is a very quick retiming operation. What's it actually doing? So if I make sure that my clip is selected and I come up to the inspector here, under the retiming and scaling options, it's currently set to use the retime process of the project settings, the same with motion estimation. What are they and what are they doing? In the bottom right-hand corner of Resolve, this cog icon, I can click on that and it will bring up my project settings. Inside here, in the master settings menu, if I scroll to the bottom, Resolve is taking the frame interpolation options in the project settings and it's using them for this clip. Currently it's set to nearest and standard faster. There's different retiming processes in Resolve and they all work in slightly different ways. So currently it's set to nearest, and if I start moving through frame by frame, you'll see that what Resolve's doing, so if I step forward one frame, then another frame, you actually only see it move once. You only see the image move once. And that's because with the nearest option, what Resolve is doing is it's just doubling the nearest frame. It's taking the nearest frame and just making a copy of it. So I can step forward a frame, step forward another frame, and then I see the movement. If I wanted smoother motion, I can come up to my retime process here and go to frame blend, which will take the two frames either side and blend them together to create this new frame. You'll see that as I step through this, what you end up with is artifacts. You can see here that that has split in two. So again, They have their uses. Frame Blend is slightly more processor intensive than Nearest. Nearest plays back quite easily. Frame Blend requires a bit more processing, and if I press playback now, you'll see I can still do this in real time, but those artifacts are quite distracting. So what else can I do? Well, there is another retime process, and this one's called optical flow. And what optical flow does is it tries to estimate, it tries to work out where the pixels are going to be in the next frame. It tries to create a completely new frame based on where it thinks objects and pixels are going to be. Now, there's different types of motion estimation that we can do within the optical flow tool. Up here in the motion estimation drop-down in the inspector, you'll see that we have standard faster, standard better, enhanced faster, enhanced better, and speed warp. Speed warp is the most processor intensive of all of them. And when I'm teaching Resolve, what I normally do is I will show users this rather than have them do it on their own system, because it is so processor intensive that it can lock up the system, and with very underpowered graphics cards might even cause Resolve to crash. With the 3090, however, I can select speed warp, and it might take a few seconds, but when I hit playback, you'll see it still doesn't look great, which isn't obviously what we're going for, but it is trying to do quite a lot here. It's trying to make up several frames whilst scaling a clip from 2K to Ultra HD, which is quite challenging. And remember, our timeline being Ultra HD, we can reduce that at any time in Resolve. If I go to the project settings and then master settings, I can actually drop the timeline resolution in Resolve without having to change any scaling options or anything like that. So I'm going to set it to be 1920 by 1080 HD. I'm then going to hit save, and you'll see that as I hit play now, we have much smoother motion and we're playing back in real time. Again, if I was to do this on a less powerful graphics card, then I'd really be struggling to play this back at all smoothly in real time. So those are a few of the features on the edit page that RTX series GPUs can help improve performance with quite significantly. Let's jump across to the color page and have a look at some of the color tools that will benefit from the same performance improvement. So, if you can see here, I've added these three clips and I've done very basic grades across all of them. The first tool that we're going to look at is quite an often talked about tool within the latest versions of DaVinci Resolve, and that is the Magic Mask object and person trackers. What the Magic Mask allows us to do is draw a line on what we want to track, or two if we want to make sure that we get the full coverage, and then track that. Basically, what it's doing is it's masking out the object for us so that we don't have to worry about going through it and keyframing or rotoscoping at all. Now what it's done is very quickly it's tracked this shark, it's made a mask for me. I turn that mask overlay off using this toggle, and I can now simply adjust my shark in the color page. It's a very easy way for us to isolate specific parts of our image that previously would have required lengthy rotoscoping work to be done to them. The same thing can be done with people. So if I jump across to my next shot here, you'll see that in the Magic Mask palette, we have in the top right the object mask and the person mask. If I click on the person mask and do the same thing, draw a line on my person, I can toggle the mask on again, and you'll see straight away that it's used that neural engine, that AI inside the GPU, because what Resolve does is it uses the tensor cores inside the RTX series graphics cards to do this AI masking. So again, if I move my playhead, I've only placed that line on a single frame. So what I need to do is I need to track that mask, and Resolve playing back at real time now. This is footage shot on the Blackmagic Ursa 12K. So this is massive resolution footage, and it's just doing some real-time tracking through our shot here. Now, I can see that it's actually got some of the seat in behind her, so I'll set it to be better, the quality that is, and straight away it's lost that. It has masked out our talent in the shot. Again, I can toggle the mask overlay on or off, and now that she is isolated, I can go in and I can just adjust specifically her. Again, removing the need for lengthy rotoscoping. This isn't the only AI feature that's improved performance within the color page, however. I can reset this node. Let's have a look at another tool. Let's have a look at the face refinement tool. This came in a previous version of Resolve, but again benefits from these tensor cores inside the RTX graphics cards. To add the face refinement tool, we can come up to the FX palette here. You'll see I've already searched for face refinement. You can use the small search button up here to search for specific tools if you happen to know the name. And all I'm going to do is I'm going to drag and drop that onto this empty node here. Straight away, it brings me to all the settings for that effect that I've just applied. And all I have to do is hit this Analyze button here at the top. You'll see straight away Resolve has started to mask her face out and mask out specific elements of her face. So it's put masks around the eyes, the nose, the mouth, the chin. All of it has already been masked out, and we're tracking it all in real time. This, again, would have been really extensive work for a colorist to go in, create multiple different power windows and track them. It's very time consuming. Whereas with these new features within Resolve, I can turn my FX overlay off. You'll see now that it's done that track, I can use the parameters in the inspector here to adjust specific areas within her face. So I could go with overall texture. You see I can smooth her skin out there, which is very handy for, or very common in beauty work. A lot of adverts you'll see will have something like this applied to them. We can go in and we can color grade the overall face in here. I can increase or reduce contrast. I can boost or reduce the midtones. I can even do a color boost in there as well. Now, if I want to adjust specific parts of our face, remember the face refinement tool masked those out for us. When it was tracking, we could see the different areas that it was masking out. And if I scroll down, you'll see we've got eye retouching, lip retouching, blush, forehead, cheek, and chin retouching as well. So I can do things like, I can go in and I can sharpen the eyes up. I could brighten the whites of her eyes. I can even go in, not that she needs it, and do some eye bag removal, or even lighten up the eyes to draw a bit more attention to them. And I can do this with all of those areas that we've masked out. So I could do the same with her lips as well. I could increase the saturation to bring a bit more color in there. I could go down to her cheeks and increase her saturation in there to add a bit more blush. The same with the chin as well. And if I fit that back to my viewer and just disable this node, you can see the changes that I've made very quickly in a matter of minutes that would have previously taken a colorist several hours when it comes to tracking and masking and getting everything just right. You might remember that I dropped the resolution of the timeline down to HD. What I'm going to do is I'm going to set this back to Ultra HD because, again, doing things in the native resolution or in the resolution that we're going to deliver at will require more processing power. So if I hit play now, even with the face refinement tool, you'll see that we're now playing back in real time. I can go back to my shark shot here, and again, we're playing in real time. All of the tracking that we've done, all of the adjustments that we're making, all of these tools work in real time with this 3090. By comparison, let's have a look what happens when I swap this RTX 3090 for my older workstation's GTX 1080. So we're back in Resolve. I've replaced the graphics card with my older 1080, and just to confirm that, if I come to DaVinci Resolve Preferences in the top corner here, and I make sure I'm on the System tab and I'm in Memory and GPU, you can see that it lists my GTX 1080 as the graphics card. Now that's a significant decrease in the amount of memory. The RTX 3090 has 24 gigabytes of memory, whereas the GTX 1080 has 8 gigabytes of memory. If I close that window now and hit play, you'll see that my shark footage plays back in real time, even with the magic mask applied, and my shot of the actress also plays back in real time. But the hard processing has really been done. The actual analyzing and tracking has already been done. So what I'll do is I'll go back to my shark shot here, and I'll just refresh or reset the tracking palette. And now if I do the same thing that I did earlier, I draw a few tracking lines on this shark here, draw another one up at the front, and now I hit track. You'll see that we actually have to wait a while before the tracking even starts, and the tracking is nowhere near as fast as it was when we were using the 3090. Now, it might not seem like a big difference, a few frames every second might not seem that slow. When you're tracking hundreds of shots for a project, all that time can add up. So for one or two shots, it might not be the end of the world, but when it all compiles and compounds down, you could be losing minutes, hours, even days of work by working on slower hardware. I'll do the same with the facial analysis on this shot here. So I'll reset that node. I will add the face refinement tool again, and I'll hit analyze. And again, you'll see it's not doing it in real time. It's actually going to take some time just to process her face and mask it all out. So comparing the time that it took to do that with the GTX 1080 versus the RTX 3090, you'll notice quite a bit of difference. Now, if I jump back to the edit page here, we still have our shot working with optical flow retiming and speed warp. Now, the timeline resolution's back at Ultra HD, but what I'll do is I'll drop this to 1080 just so we can compare with the last time we looked at this, and I hit play. You'll see that the play icon has highlighted orange, but the playhead's not doing anything. And that's simply because Resolve's taking so long to process what it's got to do with this 1080. You'll see how it just almost jumps through that timeline as it tries to catch up with itself. I can go back to the beginning of the shot and do the same thing, and we're only getting about 3 frames a second, whereas when our timeline was HD with the 3090, we were getting real-time performance. So there's quite a significant difference there. Again, this is an older graphics card. It is a GTX and not an RTX model, but you'll see how the performance improvements with the latest RTX graphics cards make such a difference to your work. That was a very quick showing of the power and performance that you can get from RTX Studio hardware. But the RTX Studio platform isn't just hardware. There is a software side to it as well. And this software side includes things like SDKs for creative applications to actually enhance and improve their utilization of the acceleration provided by RTX graphics cards, and also a more stable driver for RTX Studio cards. This driver isn't updated as regularly as the gaming driver, but with that, it's tested with specific creative applications to make sure that you have the stability that you need for a professional workflow. I hope this has given you some insight into the benefits and performance enhancements from RTX Studio hardware and software, and an insight into the performance of Scan 3XS professional video workstations. If you have any questions, please don't hesitate to contact the Scan Pro Video team.